Okay, after the sustainability and the environment, the related topics, we come to do another, let's say, different subject. This is about wastewater treatment, especially the industrial wastewater treatment, but it's going to be a kind of, let's say, a plenary lecture, but I'm going to make it as short as possible. So, just brief description, brief summary.
I should introduce you, although you don't need any introduction.
Yeah.
Professor,
I was going to introduce myself actually about the subject.
he is from Gebze Technical University, and Gebze Technical University is, in my mind, that is the best university in terms of environmental engineering. So he is the representative of this elite group. So we welcome you.
Okay, thank you. We've been, my name is Cengiz Yatmaz. I'm a professor in the Department of Environmental Engineering with my colleague, Professor colleague Nihal Bektaş, and our students. We've been working on this subject for a couple of years. This is a kind of short brief, let's say a kind of summary about this treatment of especially the industrial wastewater, but let's say the integrated processes in the sequential manner, or let's say hybrid processes. Let's start the outline, introduction and implementations of sequential treatment processes, industrial wastewater treatment processes, and conclusions. The introduction, as you know, all the industrial wastewaters has the very generated large quantity of industrial wastewater, but the contents of the wastewater is really recalcitrant, very much variety of parameters inside. It's really difficult to treat. So it's needed to make it not only one process, but a couple of processes to treat. So we've been working on the subject a couple of years. We've come to the point, and I'm going to present some results that be concluded on some kind of the variety of different industrial wastewater types. We used especially the electrochemical processes initially, and if it's necessary, the rest we use advanced oxidation processes. In the literature, there are some examples. They tried some sequential treatment processes. EC means electrocoagulation and electrooxidation, and electrocoagulation and photoelectrophantom, and electrocoagulation and nanofiltration, and also the electrocoagulation and some couple of advanced oxidation processes. So the treatment removal percentages is here. In our lab, we have used some kind of different variety of industrial wastewaters. One of is food industry, like of cake production. The other is pharmaceutical. The other one is again in the fruit industry, but aroma essence production. And the last one is the textile industry. You can see the initial COD values or TOC values of these wastewater types, but really varieties and the different kind of initial and different kind of TOC values, as you see, and the BOD values. So the BOD or COD ratios, whether they are biodegradable or chemically, or before biodegradation, it needs a kind of chemical treatment. We we have used some kind of reactor systems. This is a design of EC and EF reactor. It's a simple design. Power supply, a DC power supply, and some electrodes, especially the iron electrodes, because of EF processes it's necessary. And the next is the design of PC, photocatalytic oxidation reactor system in our lab. The electrode is iron, and the rest of the parameters, the values here, and this system, the catalysts we used, and the lamp system or the wavelength, the illumination system used here, and the parameters here in the short summary. I don't want to mention about them. The first one, we have treated by electrophantom and electrocoagulation processes the food industry wastewater. First, the EF and plus the sequential manner after the EC, the food industry wastewater, so that we obtain the removal of 20% TOC, and the next one, the EC, after the EC, after EF and EC, we increased the removal rate to 58%. These are this is the graph and the scheme of this different, using different current values. This is already published. And again, another one. This one is pharmaceutical wastewater. We have tried different sequential processes, not only electrochemical processes, but the photocatalytic processes. The first EC, EF, and initially EC and PCO, and initially EF and PCO. These are the removal rates we obtained. As you see, the best value we obtained is here. It's using especially the electrophantom processes after photocatalytic processes. These are the curves that representing the values, the end of this, and using different catalyst systems, semiconductor catalyst powders. Here, again, another food industry wastewater, but in this case, we use only the electrophantom and electrocoagulation processes, and the different way. Initially, the EC and EF and EC. The system says it works here, and especially the removal rates, 34 to 62, and 35 to 36. So trying EC and after that EF is the best way to treat this kind of water. This is the showing the graph of this basically scheme. The last one, we used the textile industry wastewater. We used only after obtaining the best optimum value from the food industry wastewater, we used only the EC and after that EF process for this kind of process. So we obtain a good removal rate after the EF process. Here 75 TOC percent, removal percent. And these, the values, especially UVDRS graph of this, and the initial value of this water, and the final value of the curve of this process. Let's get the conclusions. I said that I was going to make it really short. I think it was really short. The applications of EC and EF, and after, if it's necessary, the PCO sequential processes were investigated for treatment of different industrial wastewater. the synergetic effect of this all electrochemical and modification processes, degradation efficiency, or especially resistant or recalcitrant organic pollutants, examined with minimal operating costs, versatility, high energy efficiency, and simple equipment design. We've been also recently studying the high energy efficiency using the solar energy. And the combination of electrocoagulation, electrophantom processes lead to mineralize most of the organic matters, and then initially the inorganic ions by production of hydroxyl radicals. And that was the end of my talk. Any questions? I believe
You
this.
can talk for an additional 5 minutes if you like to. No, that's joking.
No, any questions?
Yeah, I have.
Take my time. Yeah, okay.
Of course, these are all interesting experiments. I think in laboratory scale, right?
Yeah, right. Yeah.
Laboratory scale.
We've been going on the pilot scale as well, but not the results here.
Expensive applications,
Yeah.
but I've seen negative results. Most of them are negative results because if you're dealing with textile waste and you remove 40% or 70% of TOC, they say, why not 90%? Or why didn't you try something else? Like traditional biological treatment,
Yes,
which
at the end.
90 or plus percent of conventional biologics. So why not try conventional biological system? Plus, if there is need to be, continue with those sophisticated methods.
I agree with.
You have food industry as well, right?
Yeah,
Okay,
yeah,
they
right,
produce-
right.
so it's all
Especially for this kind of
biodegradable.
water,
It's all
yes.
biodegradable.
Yes, yeah, should be. Because the BOD or COD values ratios is higher than the other industrial type of water. For food kind of industrial wastewater, it's possible to try first biodegradable any process, and after that maybe it's necessary this kind of processes. But if I say that for the other kind of processes, including recalcitrant, especially resistant organic matters, try the biodegradation processes. First try to electrochemical or a kind of oxidation processes, maybe in the end, after 70% biodegradable, any kind of processes, it is possible, yes, it's okay.
And I advise all my colleagues
Yeah.
and respected colleagues to abandon BOD if you can, because there are now respirometric tests to tell you the biodegradable fraction
Yes.
of the substrate, and BOD is difficult and always depends on the technician who runs the test, and
Right.
most of the time he is wrong, and then you have a wrong result. For instance, for textile industries, it shouldn't be like 0.20 something. Textile, the biodegradable part should be something like 80%, depending on the type of textile. If you're talking
Yeah,
synthetic
you're right.
textile, of course that's different. But like denim processing or just normal textile, the biodegradable fraction should be much more. And the BOD does not reflect that, unfortunately.
Yeah, you're right. Because into our lab, different kind of textile wastewater types come to that. When we make the first initial parameter tests, we get different results. So it depends on the source.
We have now a respirometer,
Yeah.
which